Hello there. This problem is asking us to use sigma notation to write the sum and then find the answer. So this is going to use writing the apparent nth term and then our sigma notation. So the sigma notation for this problem would, I like to use k as my subscriptor, I guess, here. So this expression, here's my counter, 1, 2, 3, and it goes all the way up to 12. So when I set this up, I'm going to say it's a 5 over 1 plus k. I like to check it real quickly here too. If I were to do k equals 1, I do get 1 plus 1. K equals 2, I get 1 plus 2. Everything's nicely set up. And the top number, of course, is where I stop. So that's 12. The problem also asks us to find the sum, so I'll use the calculator for that. Ooh, bunch of crazy stuff in there. There's our summation notation, and I'm going to do, I use x in here just for the heck of it. X equals 1 to 12 of the expression 5 over 1 plus x. Answer is, a decimal. Can I change that nicely? Nah, we'll just leave it like that then. 10.9-ish. 10.9-ish. Okay, problem number 2, or the problem over here in quadrant 1, is 1 minus 1/2 plus 1/4, etc. So that's, again, summation notation. Here we have the numbers 1/2, 1/4, 1/8, so I can see the powers of 1/2 occurring. And I also see that I am alternating between positive and negative, so I'm going to put my -1. Now, since we need the first term to be positive, I'm going to make the exponent on the -1 to be n plus 1, because that's going to make the first term, 1 plus 1, become -1 squared, which is positive. And I need this to be 1/2 to the 0th power. So the exponent I'm going to put over here is actually going to be an n minus 1. Now again, let's check it. Whoops, I mean to put k's, don't I? Let's put some k's. So if we look at this at the first term, 1 plus 1 is 2, -1 squared is 1, so that's going to be positive. And 1 minus 1 is 0, 1/2 to the 0 is 1, so that's successful. Let's check the next term. K equals 1. Or k equals 2, sorry. 2 plus 1 is 3. -1 cubed is negative. That's happy. 2 minus 1 is 1. 1/2 to the power of 1 is 1/2. That's happy. So we just have to figure out how far we had to go now. So we need to get up to this term right here, and that is, of course, 2 to the 10th is the number that we have to get up to in the denominator. We're always subtracting 1, so that means we'll want to go up to the 11th term. The 11th term. Let's check it. -1 to the 11 plus 1 is going to be even power on top. That's a positive. And 11 minus 1 is 10, and that's what gives me 2 to the 10th. So this is the correct summation notation. Now what is the actual number? Math, summation notation, and we'll go x equals 1 to 11. And in here we have a -1 raised to the power of x plus 1 multiplied by 1/2 raised to the power of x minus 1. X minus 1. Which comes out to be... can we get a decimal fraction on that one? Yay! There we got a fraction. 683 out of 1024. Okay. Next, asking us to do, using the formulas and facts, see if we can figure out what this is. Okay, so first of all, we can use the facts in order to pull the summation notation through the pieces here. So we end up getting a 3 times a sum of a k squared minus 2 times a sum of a k plus the sum of 1. Okay. Now by the formulas, the sum of the k squareds becomes 3 multiplied by n times n plus 1 times 2n plus 1 all over 6 the summation of the k's becomes n times n plus 1 over 2, and the sum of 1 just becomes n. Now n was the top number, which is 10, so that means we need 3, 10 times 10 plus 1, which is 11, times 2 times 10 is 20 plus 1 is 21, over 6, minus 2 times, n was 10, so this is 10 times 11 over 2, plus n was 10. So the answer is going to be 3 times 10 times 11 times 21 over 6 minus 2 times 10 times 11 over 2 plus 10. Looks like 1055. And for our final problem on this page, this one recommends to distribute first, so let's listen to that. Might be a good hint. We have the summation of k squared plus 2k plus 1. So we get the sum of k squared plus 2 times the sum of k plus the sum of 1. Okay, so what do these become? The sum of the k squareds is n times n plus 1 times 2n plus 1 over 6 plus 2 times, what's the sum of the k's? N times n plus 1 over 2 plus the sum of the 1's, which is n. And in this case, we're summing from 1 to 17, so this will be evaluated at 17. 17 plus 1 is 18. That would be 34 plus 1 is 35 over 6 plus 2 times, again with the 17, so 17 times 18 over 2, and then plus the simple little 17 off at the end. So what are we getting here? 17 times 18 times 35 over 6 plus 2 times 17 times 18, and that one's over 2, and then added to 17. So there we get the answer of 2,108.